Hello people, welcome one and all to Jojo's Learning Club.
Hello guys, welcome back to my channel once again, Jojo's Learning Club. So this is the part 7 on permutation and combination on in this section I will discuss on further work problems on permutation and combination. If you have not watched the videos on my fundamental principle of counting and permutations, theorems and explanation, and also work problems on permutation, you can always check my playlist on permutation and combination where the entire section is discussed. And on this section, as a small reminder, I won't be doing the entire solution for all of these problems because it's really time consuming and it will just elaborate the length of the video. So I will discuss until the last section, and please find the final answer. You can either comment under my video or you can also send me. I will correct it for each of you guys. Okay, so let's directly start with the first problem. What is the number of ways of choosing 4 cards from a pack of 52 playing cards? In how many ways the 4 cards are of the same suit? Before discussing about these problems, let's recall. So you all have played cards, I hope that, and you all know that there are 13 clubs in it, right? And 13 diamonds in it, diamond cards in it, and 13 spade cards in it, right? And the last section, what it is, there are 13 hearts in it. So in total there are 52 cards, and out of all these there are 12 face cards, right? So if you have played cards, you will be knowing that there are 13 clubs, diamonds, spade and heart. Okay, now let's discuss the first problem. 4 cards are of the same suit. It is said that there are same suit means these either can be selection from clubs, or it can be also selection from diamond, or it can be selection from spade, or it can be selection from hearts. So there are 4 possibilities, right? From the first selection from club, then the next selection from diamonds, then from this third selection from spade, or the last selection from heart too. So what are the possible number of combinations? These are all same, right? So I can write it together as 14 13C4. So this is the answer for the first section in the first problem. I hope it's clear, right? So what's the second question? 4 cards belong to 4 different suits. Then there are 4 positions, right? That 4 positions, 4 cards. First position can be filled by like what? 13C1. From the 13 cards, 1 possible into 13C1 into 1. Again, what into 13C1 into 13C1. Why? It is 1 card from club, 1 card from diamond, 1 card from spade and 1 card from heart. So in total what it is? 13 into 13 into 13 into 13, because 13C1 is 13 itself. So that's from where you get 13 raised to 4 is the answer for the second section of the first problem. This is why I said it's a long, the calculation will take a long time, and that's why I'm not doing the final answer for each of these problems. I will discuss till this section on each of these problems. Okay, so this is the second problem, and now let's discuss the third problem. The third one is the face cards. So what are the number of face cards in the problem? I already discussed that on total together we have 12 face cards in these 52 cards. From this, if we make a combination of 4 cards, what it would be? 12C4. And that's the answer for the third section in the problem. And what is the last and fourth problem? Fourth section. 2 red cards and 2 black cards. That is, in total there are 2 red cards and 2 black cards. 2 red cards can be selected in 26C2 ways. And the next 26 black cards can be selected in 22C2 ways again, because both a combination of 26 red cards and 26 black cards. They in total make 52 cards, and the 2 cards can be selected from that is 26C2, and 2 black cards can be selected in 26C2 again. So that's the answer for the fourth section. Okay, now let's discuss the last and the final section. Cards are of the same color, that is either it can be from black card or it can be also from red card. So it can be also 26C4 from the red card, and it can be also from 26C4 from the black card. Right. So in total, what are the possible number of combinations? 26C4 plus 26C4. That is 2 into 26C4. This is the answer for the problem number 5. Okay, now let's discuss the first section is over, and now let's discuss the second section. It is also interesting. Determine the number of 5 card combination out of a deck of 52 cards if there is exactly one ace in each combination. So what are the number of ace in these cards? There are 4 ace, right? And the left card is 48 cards are left, and out of these 52 cards, 4 cards are ace and there are less 48. So in total there are 52 cards in this selection, right? So from this, what it is said, what are the possible combinations if there is exactly one ace? That is, you have to, from these 4 you make a one ace selection, and the rest cards, total number of cards selected are 5. So 1 is already taken. So what is left over here? 48C4. And this is how you make the number of possible combinations for this. Once again, I will say that there is 4 cards, 4 ace cards, and out of these you take 1. So 1 is already selected. So we are in total taking 5 selections. So in total 5 minus 1, 4. And these 4 cards are taken from the rest of the cards. When 4 ace are there, the rest of the cards are 48 cards are left. And from these 48 cards, we make a selection of 4 cards. And this is what the answer for the second problem is. Okay, now let's discuss the third problem. In how many ways can one select a cricket team of 17 players? So we have to select a cricket team. So in a cricket team there are 11 players, right? And these 11 players are selected from 17 players are there. Okay, next, in which 5 players can bowl? It is said that out of these 17, 5 can bowlers. Okay, and the rest left is 12. Okay, 12 plus 5, 17 can bowl. What are the possible combination if the team must include 4 bowlers? So it is said that from this you have to select 4 bowlers from 5 bowlers, right? From 5 bowlers you have to select 4 bowlers. So 5C4. So to make a team of 11, already 4 members are selected. Then what is the rest number of people? 4, 11 minus 4, that is 7. So these 7 rest of the players can be taken from these rest 12. That is 12C7. Okay, if you didn't understand the problem, I'll repeat it once again. We have 17 players. And it is said that out of these 17 players, 5 are bowlers. And it is also said that from these 5 bowlers, you have to select 4 bowlers. That is why it is 5C4. That's clear? Okay. In total, you have 17 players. From these 5, you have already taken 4. And now, the rest left is 12 people. And out of these 12 people, 4 are already taken. So, 11 minus 4 is 7. So, that is why 12C7 is written. And this is the answer for the third problem. I hope it's clear. The last and the final problem in the entire section on permutation and combination. So let's see. Fourth problem. A committee of 7 members has to be formed from 9 boys and 4 girls. So there are 9 boys involved in the committee and 4 girls. Okay. And what it is said? In how many ways this can be done if the committee consists of exactly 3 girls? So in committee you have to always remember that we need 7 people in the committee. And it is said that first problem is that you have to take exactly 3 girls. That is, from this 4, so you have to take a combination of 3 girls from it. And also, and it is said that there are 9 boys, 3 are already taken. So what are the left number of boys? 3 members are already taken, as 3 girls are already taken, and the rest selection is from boys. So in total there are only 7 members in the committee. So 7 minus 3, what it is? 9C4. Okay, I hope it's clear. And the B section in it, at least 3 girls. At least 3 girls means the combination can be possible with 0, 1, 2, 3. Sorry, at least. Sorry, this is at most. This is at most 3 girls means maximum of 3 girls. That is 0 can be a possible, at most it is said. So maximum. So 0 girls can be possible, 1 girl can be possible, 2 girls can be possible, and 3 girls also possible. And what is the case when it is at least? At least means a minimum of 3 girls. So there are total of 4 girls. So what are the possible combinations for it? With 3 girls and also with 4 girls. So what would be the answer for the at least? From this, first one is 4C3 into 9C4 itself, the same itself, right? This can be one possibility. What next it is, from you take all the girls and you have already taken 4 members in the team. So what it would be? 9C3. So this is the first possible with 3 girls and 4 girls. In total, remember that committee should always have 7 members. So when you have taken 3 girls, so there are left 4 boys. When you have taken 4 girls, there is left 3 boys should be taken from these 9 boys. I hope it's clear. And the last section, C section on it, is again, don't get confused with it. See, at most 3 girls means what it is? The maximum 3 girls can be possible. That means I take a combination with no girls into all are boys in this term. Okay. And what is the next possible? 1 girl is taken and 6 boys are taken. So from one girl is taken from 4 girls and 6 boys. So 9C6. What is the next combination? 2 girls are taken and 5 boys. So 4C2 into 9C5. And the last and the final possibility is what? 3 girls are taken and 4 boys are taken. So 4C3 into 9C4. So this is the answer for the problem number C in 3. Okay, what was the question once again? A committee of 7 members. You have to form a committee of 7 members, and out of this exactly 3 should be taken, 3 girls should be taken. Then what is the answer? From a member of 4 members, you have to take 3 girls. What are the possible combination? 4C3. When you take 3 members in the committee, the left are 4 boys should be 4 boys should be taken. And for the selection of boys, there are total number of 9 boys. From these 9 boys, you have to take 4 members. That is possible with 9C4. And for the next second problem, it is said that at least 3. That is, it can be possibility of with 3, it can be also possibility with 4. That is what explained here. And in the last problem, it is at most 3 girls. That is a possibility with no girls in the committee, a possibility with 1 girl in the committee, a possibility with 2 girls in the committee, and a possibility with 3 girls in the committee. So I hope it's clear, this section. This was a very interesting section. Please find the answers for these problems, and either you can email me, I will do the correction and send you back, or you can also comment under my video. I'll be checking that. Okay, so that's all for these sections, and on my next video I'll come with an interesting topic, probably on exponential functions. So let's see you over there. Bye bye, take care and have a nice day.